in the WhatsApp group. So in this course, basically the structure of today will be basically an introductory session, and I'll be discussing the structure of the course, the class timings, and what will be the method which I will be using for teaching. And you can obviously in between you can just unmute yourself and you can talk and you can let me know if you have any suggestions about the class, anything. You can please let me know. You can either you can type in the chat box or you can unmute yourself and you can speak. So basically this will be 2 hours of class on every Friday, every week once on Fridays from 6:30 to 8:30. So I was supposed to take the class yesterday, but due to some reasons I couldn't take the class. Yeah, Mr. Javed, can you please mute yourself? Do you want to say something?
Sorry for interruption.
Okay. No, you can tell me if you do you want to say anything? You can tell. Okay, fine. So basically there will be 13 sessions, 13 live sessions. I'll be taking 2 hours each on Fridays, 6:30 to 8:30. So if there is any change in the class timing, I'll let you know through email as well as in the WhatsApp group. So basically this course will be dealing with the numerical methods, the what are the different computational numerical methods, and also I'll be dealing with how to implement these numerical methods in MATLAB. So each and every method I'll be discussing the mathematics behind that. I'll solve some problems and how to implement that using MATLAB. I'll be discussing all those things. Just a second. Okay. So basically today I'll be discussing what will be the contents of the class, in which class I'll be discussing what topics, and I'll be discussing MATLAB first. I'll be any method which I take, any numerical method which I take, I'll be discussing the theory behind it. I'll be solving some problems based on that, and I'll show you in MATLAB how to code that and how to understand and how to visualize the thing in MATLAB also. So maybe every one of you will not be familiar much with MATLAB. So what I've decided is first class I'll be discussing briefly about MATLAB, the basics of MATLAB, which has nothing to do with numerical methods, obviously. First half an hour or 15 minutes, I can give you an introduction about MATLAB, and then I can go into the how to code, how to write the programs for the different numerical methods. And I'll not be using any PowerPoint presentation. I don't like it actually. So I'll be writing whatever I speak, or I'll be writing in a pad, this notepad, and I'll be uploading the PDF of these documents in a drive link, which I'll be sharing you through email as well as in WhatsApp. So is this mode of teaching fine for you, or you want something else? You can, any one of you, is it fine? Is it okay for you? And or you can tell me if you have any query or anything about the class timings, anything you can tell me. Do you have any queries?
No, sir.
Okay. So is the class timing fine for you? Because you are from, I think many students are from a different country, Bangladesh. So is it fine? The timing is fine for you, right?
Yes, sir.
Okay. Okay. Okay, fine. So I'll be starting the class. So first I'll discuss about numerical methods, why there is a need to, why we need to switch to numerical methods instead of the analytical methods which we have. Then I'll be discussing the different numerical methods and the MATLAB coding behind it. So first we need to understand what is a numerical method. So for that, before we go into what is a numerical method, I'll just give you some examples. Just let me know whether you are familiar with this. So basically, suppose when we have learned mathematics in our childhood days, we were taught about addition, subtraction, multiplication, the different operations, right? So we know that if we add 2 and 2, it gives us 4, right? This is an exact solution. Means there is no error involved. Means 2 plus 2 will give you 4. It will not give you 3.99, neither 4.01, right? So it is an exact solution. However, when we went up our in our senior classes, we learned about square root, cube root, the fourth root, all these things, right? So if I tell you what is the square root of 2, everyone will tell it is 1.414, right? But is this actually correct? Is this an exact solution or an approximate solution? It is not an exact solution, right?
Explore.
It is an approximate solution because the square root of 2 or square root of 3, these are called as irrational numbers, right? These are irrational numbers. And for our simplicity, what we do is we basically try to approximate this the square roots or the cube roots, these irrational numbers, up to certain decimal places. Otherwise, the square root of 3, if we try to express, it will be an infinite number of digits after the decimal point, right? Similarly, we have some constants which is known as pi, which is 3.14. We express it like 3.14. But is it exactly 3.14? No. The exact value, it cannot be determined. It is an infinite infinite number of digits after the decimal points. So these are all approximate numbers, right? Or approximate solutions. Suppose you have a equation like x square minus 4 equals to 0. So if we try to solve this equation, we will basically get two solutions, right? It will be x equal to 2 and x equal to minus 2. So these are my exact solutions. So these are my exact solutions, right? Just a second, someone is trying to enter, I think. Okay, so what happens is exact solution. However, if we have an equation like this, x square minus 3 equals to 0. So we have basically, again, two solutions for this, x minus root 3 and x plus root 3, right? So x will be minus root 3 and plus root 3. But is it an exact solution? Because we can write it as minus 1.732 and 1.732. So we are rounding it off up to a particular decimal place. So that's why we are getting a solution. However, these are not exact solution. We are approximating the solution. These are called the approximate solutions. So whenever you try to solve an equation, you can have two types of solution, either an exact solution or an approximate solution. Is this clear to you? Any doubts?
No, sir.
Okay, fine. So now I'll give you another example. Like suppose we have an equation like say x minus e to the power x equals to 0. If we have an equation like this, or let us say not like this, x minus sine square x equal to 0. So will you be able to solve this equation by any standard analytical technique? Anyone? Can you find the value of x from here using our any techniques? No,
No,
right?
sir.
No. However, if we have an equation like this, x like the previous one I described, so from the here we can get an exact solution for this x. However, here in the first case, that is x minus sine square x equals to 0, we don't get any solution using an analytical technique. So this type of equations are known as transcendental equations. This type of equations are known as transcendental equations. So our normal analytical techniques of solving any equation, using those techniques, we cannot arrive at a solution for x in this type of equation. There can be several other examples can be given, like x minus log x equal to 0. Or we can have x square minus cos x equals to 0. Like this, we can have infinite number of equations. So these are called transcendental equations. So we cannot find a solution for this. So we cannot find a solution for this, for these equations using standard analytical techniques. So we need to find some other technique which gives us the solution, for this kind of equations. So that is where comes our numerical methods. So in order to find solutions for this type of equations, we need numerical methods, right? So what is the need for numerical methods? Is it clear to everyone?
Yes, sir.
Okay. So first, whenever we study any topic, we need to understand what is the motivation behind it, right? So if you think this example I gave you for some equations where we don't have an exact solution, right? So suppose in our real life, if we imagine the real life, we can think of like the any kind of physical problems. If you think about like the heat conduction problem, suppose there is a layer of 2 3 layers of a cylinder, and you are trying to find a source is supplied, a heat source is supplied to the center of the cylinder, and you are trying to find out what is the distribution of the heat along the 3 different layers. So in any kind of problems, there is nothing called, in the real life, there is nothing called exact solution. So any problem if we want to solve in our real life, we will always get an approximate answer. And in order to find any approximate solution for any equation, we will not have any analytical techniques for that. So we need to understand that any solution of any equation in our real life, that needs to be done through numerical methods. So this is the importance or the motivation behind studying the numerical methods, right? So now I list down first whatever I told, I'll just list it down. So we need, so till now we have studied about the motivation behind numerical methods, right? So the main motivation is that all real life problems, so all real life problems are defined by complex nonlinear equations, which we cannot solve using our simple analytical techniques. Solve using analytical techniques. So for this type of equations, we need to find some technique which gives us an approximate solution. And the basic, the basic, if we say the basis of any numerical method is, we will not, means we will iterate. Like suppose I have an equation like this, right? X minus log x equal to 0. So what we do here is, in any numerical method, we have an initial value like x minus log x equal to 0. We don't know what is the solution, what is the value of x for this. What we do is we assume a particular value, an initial value you can rather say, and based on that initial value, we try to approach towards the solution. Like x minus log x is 0, right? So we can assume an initial value say 0.5. Using that value of x, we see whether it is satisfying our equation. If it is not satisfying, then we switch to a different value of x, which is obviously dependent on the numerical method which you are which you are using. So this is the basis of an any numerical method. So what we do is we approach towards an approximate solution. We approach towards an approximate solution, right? So these methods by which we approach towards the approximate solutions are called as numerical methods. Are called as numerical methods, right? So before going into numerical methods, we need to understand this motivation, because why we are trying to solve. Like numerical methods is basically to find solution to an equation. So you might think that we have already different techniques for solving a particular equation. So why we are going there? Why we are trying to find some other method, some other say complicated method to arrive at the solution? So this is the basic motivation, because any solution, any equation, any problem in our real life, this will be described by different non-linear equations like I described it here. X minus log x equal to, not even simple like this. So basically we will any kind of real life problems, if you can think, or if you in engineering, let us say in any engineering problem, like if you are from electrical engineering, I am from electrical engineering background, I can tell you. So we have studied the simple circuit analysis, right? The nodal analysis, the mesh analysis, all those things. So there are simple equations. However, when you involve say an inductor, a resistor, and a capacitor, or combination of all these things, and you try to find out the mesh current or the nodal voltages, obviously there will be complicated equations, right? So there we need to understand that if we use our analytical techniques, we cannot arrive at a solution. We need to devise, we need to formulate some other techniques. It may be iterative, it will give you an approximate solution, not an exact solution, but yes, we need to go there, we need to approach towards the approximate solution, right? So this is the basic understanding or the basic motivation behind the numerical methods. So let us keep this class as interactive. Otherwise, I'll just speak and you people will keep quiet. So that will be a one-sided communication, which I don't like. So you can tell me any one of you. You can unmute yourself and tell me. Um, have you, first of all, have you studied this course numerical methods anywhere before?
So I have a query here that do we
Yeah.
have a mathematically rigorous proof that we do not have the solution of x minus log x is equal to 0?
Yes. Could you come back again?
Yes, so my query is that do we have, I mean, a proof or, I mean, something mathematically rigorous formulation that we cannot get the exact solution of this equation x minus log x is equal to 0?
Okay. So you are telling, is there any proof for that?
Yes, yes.
Because as far as I can tell, okay. So you can use like in MATLAB, we can plot y equal to x curve and y equal to log x curve. Uh, we can find a solution, the intersection point of these two curves. But again, that solution will not be exact. Proof, I'm not sure of it. I'll check and get back to you. But uh, any value means if it is an irrational number, like if the value of x is an irrational number, you cannot exactly say what is that number. Like I just now I described for say square root of 2 or square root of 3. Just from we are telling this from intuition. There is no most probably there is no mathematical proof for this. But we are trying to approximate the solution. Like square root of 3 is not exactly 1.732. It is something more than that. But for the sake of representation, we are truncating that particular value and we are approximating it with some solution.
Yes, that's okay. But then,
Hmm.
even by using the analytical method, if we can come up with an approximate solution, say, like the equation x square, x square, say, x square minus 9 is equal to 0, or something, say,
Hmm.
I mean, x square minus 3 is equal to 0, say, for instance.
Hmm. Hmm.
So we get the values as plus minus root 3. It is okay. I
Hmm.
mean, we use the analytical method and we got a quantity and whose value can be approximated. Say we are
Hmm.
not as such. So the actual problem is to get the value of x in the
Hmm.
equation, say x square minus 3 is equal to 0, and not to
Hmm.
get the exact value of the square root of 3. So it makes sense that if I using the analytical method, if you can come up with a value and whose value can be approximated later on. So I mean, in which situations we do use, I mean, the numerical methods. I mean, and first of all, how to target and approach a problem, that I mean, to know for sure that okay, I cannot use the analytical methods here, so therefore I need to switch to the numerical methods.
Yeah, that is a good question. So there is a difference between these two things. Like two equations, I'll tell you. Like first equation I described x square minus 3 equal to 0. Yes, it is using an analytical technique. I am getting a solution for that, which is plus root 3, which can be approximated or rounded off to a particular value. So this is by trial and error. You have to find out whether an equation we can solve by analytical approach or numerical approach. Because this, yeah. Okay. So this type of equations, like this transcendental equations, x square minus 3 equal to 0 is not a transcendental equation. It is a simple algebraic equation. The problem there is we are not getting the exact value of x. So there is that has nothing to do with numerical methods. So that I described just for telling you the difference between an exact solution and an approximate solution. That can be solved analytically using our normal analytical approaches. But when it comes to transcendental equations, so you can ask me how can I identify a transcendental equation? So basically, a transcendental equation is a combination of your algebraic variables, trigonometric variables, and logarithmic variables. So if these variables are combined and they form a particular type of equation, we call those as transcendental equation. And till now, we don't have any analytical techniques to solve those transcendental equations. So there, when you don't have any solution for an analytical solution for those kind of equations, we need to go to the numerical techniques. Is it
Okay.
clear?
Yes, yes, I understood. Yeah, thanks.
Okay. Yes, Akash, you have raised your hand. You have any doubt?
Yeah, so hi. So x
Uh,
minus log x, I think, has no solution. So it doesn't intersect x log x.
hmm,
X has higher growth than log x. And to answer that particular question, x square minus 3, what I believe is, suppose I want to approximate root 3.
hmm,
So to do that, maybe I can consider x square minus 3 equal to 0, and I can initialize, I can iterate. So
hmm,
our objective is to get the approximate solution of root 3. So
hmm.
that's why we
Yes.
can use that numerical technique actually. I mean, we can easily solve it. X square minus 3 equal to 0. We know it's plus minus root
Hmm,
3. But
hmm.
to get an approximate root 3, we can use that technique. I mean, iteration or something like that.
Yeah, yeah, correct.
Thanks.
Anyone else? Any doubts? Or you'd like to share something? Akash, you can lower your hand.
Yeah, done.
Hmm. Fine. So no other queries, right? So, to other side, what I wanted to ask is, are you all familiar with numerical methods? Means, have you come across this course anywhere before? Especially our students from Bangladesh. Can you let me know whether you are familiar with the numerical techniques, or because you are in majority, so uh, I have to design the class in that way. Are you familiar with numerical methods, MATLAB, these platforms? Are you familiar with these things?
Yes, sir.
So
It
can
can
you tell
solve
Yes, sir.
anyone of
Newton-Raphson
you,
method.
anyone of you, can you tell me what all you have studied in numerical methods? So you are all of
I
you
can.
are from BTech background, right?
Yes, sir.
Okay. Anyone of you, can you tell me what you have studied in numerical methods? What are the different techniques? Some of the techniques at least.
Newton-Raphson method.
Okay. Anything else?
Gauss-Seidel method.
Okay. So have you implemented these things in any MATLAB or any programming platform? Yes, you can tell Dr. Srimanti.
Yeah. Hi, sir.
Yeah.
It's Srimanti.
Yeah.
I'm their faculty member
Okay.
from
Okay.
Daffodil International University.
Okay.
So they studied these numerical methods in the level 2. We call here as level 2. That is second year BTech
Okay.
as per
Okay.
India.
Okay.
So normally they have studied Simpson's one-third rule, then
Okay. Hmm.
Gauss-Seidel method, numerical Rapson, and then
Hmm.
after that semester they apply those techniques in power system analysis, like in load flow study and all. And
Yes.
also they have applied these things in electromagnetic fields. So
Okay.
this is the thing.
Okay. Okay. Fine. I got it. Fine.
Thank you.
Thank you, ma'am. So, okay. So first we will start with the most basic iterative or numerical technique, and we will see how we can find the square root of a particular number. So how we can iterate and find out what is the square root of a particular number. So this algorithm is basically known as Hennon's algorithm. So first I will be teaching you how to find out the square root of that particular number, approximate it, and then I will try to extend it to the cube root or the fourth root, all those things. So we will basically here, the basis of any numerical method is we have to develop an iterative technique or an iterative formula to find out the value of that particular unknown variable. So suppose you have a equation like, say, x square equal to n. Okay, x square equal to n. So basically we try to find out, so we know what is x, right? X is plus minus root n. This is using our normal analytical approach. So in order to approximate the square root of n, we will use an iterative technique here. So how we will do that, we will see. So we can write it as x equal to n by x, right? So basically here we will try to find an iterative formula for x. So x equal to, we can write it as x equal to n by x. If we divide it by 2 on both sides, it is x by 2 equal to n by 2x. So this we can just manipulate and we can write it as x by 2 plus n by 2x. So this we can write it as x equal to, so this is our iterative formula. So as I told, for most of the numerical methods, first, in order to find out a particular value, we have to assume a initial solution. And from that initial solution, we will use our iterative formula and we will try to find out what is the next value of the particular solution. So this is our iterative formula, right? So now we will see an example and we'll see how the same thing after I complete it, I will show you using MATLAB also. So how is it going? So here we will try to make a table. So what is x new? Basically, x new is half of x plus n by x. So you might have a confusion here. This is the value of x for the next iteration. That is updated value of x. And this x is the present value of x. So suppose we are trying to find the square root of 5. So our n is 5 here, let us say, for this example. Okay. So the first iteration, we will number it as 0th iteration. Okay. So what is x of 0? X of I means here the number of the iteration. So I is at the present condition, I is 0. So what is x of 0 here? So x of 0, you have to assume a particular value, which is known as the initial value. So when you are given a problem like this, you will be given an initial value for that. Correct. So here I am telling the initial value is given in the problem as x of 0 is 1. So x of 0 is 1 here. So your n is 5, right? So it is basically 5 by x of I. So 5 by 1 is 5 and x new, if you substitute here, it is half into 1 plus 5, right? It is 3. Now we will go to the next iteration. So what is x of 1 now? So after the 0th iteration, we got x new as 3. So we will bring that 3 as the value of x for the next iteration. So for iteration number 1, your x of 1 is 3. And 5 by x of 1 is 5 by 3, which is 1.666. And if we do this x new, it is half into 3 plus 1.666. So this will give you 2.333. Now for the second iteration, value of x is 2.333. 5 by x of 2 is 2 point. If you do this using calculator, you can find out easily. It is 2.143. And if you substitute it here, you will get it 2.238. So now you might ask me that how far do we need to continue? Means for how many iterations will we repeat this technique? So the answer is you have to see for every step. First step value was 3. Next step value is 2.3, 2.333. Next step value is 2.238. You can see here the difference between the values in the next step, successive steps, is reducing. So once it is reducing, so that means you are in the right track. So as we increase the number of iterations, we will slowly approach towards the exact solution. Now you don't know what is the exact solution. So at every step, you have to calculate the difference. And your tolerance level will be given in the question. Say I am telling here, your tolerance level is 0.001. That means if 3 digits after the decimal place is same in the successive steps, you can stop your iteration. Is it clear?
Yes, sir.
Okay. So for the third step, I will be using this 2.238. 5 by 2.238 is 2.236. And if we calculate this x new, it is 2.237. So you can see here, in the successive steps, it was 2.238 in the previous step. Now it is 2.237. So 2 places after the decimal is almost is same. So slowly you are approaching towards your goal. So now, if we go for the next step, fourth step, so it is 2.237. 5 by 2.237 is, I'll just calculate. It is 2.235, and this one is 2.237 plus 2.235 into half. It is 2.236. So again, what is happening is 2 places is same. So you have to continue this process till your tolerance limit is met. So now you can understand this. One of the disadvantages of these numerical methods is it is computationally very expensive. Like the analytical techniques we can solve using our manually we can solve those equations. But here what is happening is, so here I have given you the tolerance limit as 10 to the power minus 3. If I would have given you the tolerance limit as say 10 to the power minus 9, what would you have done? So that means basically 9 places after the decimal you have to take, and you have to calculate for every step until 9 places after the decimal is almost same. So here arises the need for a computational tool to solve your numerical methods. So numerical methods, any kind of numerical methods, whatever you study in this course, has to be implemented in MATLAB. Any kind of programming platform rather, not only MATLAB. So I will be using MATLAB for this particular course here, and we will see that here we could, by manually we could solve up to 4 steps, and it took so much time, you could see. However, in our computational platform, if we try to solve these equations, within a few seconds you can solve these equations. Okay, so one more thing I wanted to ask you. Yes, Mr. Yes, you want to say
Yeah,
anything?
yeah, I have a query here that since we do
Yes.
not know the exact solution in advance, so
Hmm.
how to know that whether the tolerance limit has been had been reached or not?
Tolerance. Okay. So just now I described this, like every successive step, you have to compare the value with the previous step, and you have to find the difference between them. So like in the fourth step, the value is 2.236, right? And in the previous step, the value was 2.237. And we subtract these two values and we see what is the difference between these two values. So if it is lower than the tolerance level, uh, if it is lower than the tolerance level, then we can basically go forward. Means we can stop our iteration and we can find out the we can tell that is the particular solution using our manual technique, whatever is there.
Yes, yes, yeah, I understood. Yeah, thanks.
Yes, Akash.
Yeah, so I understood the algebra that x is half x plus n by x. So it seems like it is Newton's method. I mean, so this formula looks like Newton's method. So I mean, this
Mm,
method does it have a geometrical interpretation?
no, this Hennon's algorithm doesn't have a geometrical interpret. It has an only an algebraic basis.
Oh, okay, 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 fine. Thanks.
Hmm. So we can easily write a MATLAB program for. So one more thing, Dr. Srimanti, are the students familiar with MATLAB, or which programming platform are they familiar with? Can you let me know?
Yes, sir, they are.
They're familiar with MATLAB, right?
Yes, sir, they are. They already
Okay.
have course. Am I audible?
Okay. Yes, yes, you are audible.
Yeah. Yeah, they have one laboratory-based course on numerical
Okay.
methods.
Okay.
So they are familiar. Yeah.
Okay. Fine. Fine. So, okay. So that will be easier for me to teach them. So this we can, I'll show you how to write this code in MATLAB, and we will see how the error, if we increase the number of steps, how is our error reducing? We will try to see this through MATLAB. Okay. Okay. I'll share my screen, the MATLAB screen. Is the MATLAB screen visible? Can someone confirm?
Not yet.
It's not visible. Okay,
Not yet.
just a second. Now is it visible?
Yeah. Yes.
Okay, the MATLAB screen is visible, right? Okay. So here you can see in the MATLAB, basically I'll give you a brief intro first. If you are not, anyone not familiar, means you have not used MATLAB, you want to learn MATLAB from the basics. Anyone is there like that? You can raise. Okay. Okay, fine. Okay. Okay, then fine. I'll describe this one code. I'll describe for every line. I'll describe how I have written it. From next code onwards, I'll show you only the results. Okay. Just a second. So as you can see in the manual method which I showed to you, you have to basically iterate. Like every time you have to repeat the same thing with an updated value, right? So here, first line, this if I write anything in for those who are new to any coding platform, there are some students I think. So for them, I am just describing. Just those who are familiar, please bear with me for a moment. So if you write anything under percentage symbol, that is called a comment. So that means that line will not be executed, and that is for only for information. So here, when you start MATLAB, like I have written here, finding the square root of a number, right? And maximum tolerance, this is not needed. So here what I have done is there are different loops in MATLAB, right? To iterate over a particular, means in order to iterate, we have basically two kinds of loops. One is called the entry control loop and the other is called the exit control loop. So I'll not go into the details of all those things. So basically in MATLAB, we have these two kinds of loops, the entry and exit control loops. In entry control loops, we have the for loop and the while loop, whereas an exit control loop, we have the do and the do while loop. So I'll not go into the difference of all those things. So what it basically does is when I go to this line number 9, that is the while loop. So I am whatever is there inside the while loop, that is line number 11 to line number 19. All these statements will be executed uh, till the condition for the while is met. Like in line 9, we have the condition for the while loop, right? So what I have given here is this tall is greater than equal to 1e minus 9. So until this condition is met, the statements inside the while loop will be executed. And whenever that condition is met, we will move out of the, sorry, I told the other way, means till the condition is met, we will be inside the loop, and once okay, sorry for the interruption. So till the tolerance is greater than 1e minus 9 basically means 10 to the power minus 9, right? So till the tolerance is greater than 10 to the power minus 9, this while loop will be executed. That is, the statements inside the while loop will be executed. And uh, once it is less than 10 to the power minus 9, we will move out of the loop. That means your condition is satisfied and we are done. So here, if we just try to find out what is happening here. Okay, so this is for not for the square root. Okay. Okay, I'll write the code for the square root also. This CLC and clear all, these are the statements in MATLAB to clear the screen and to clear. CLC is for clearing the screen, and clear all is for clearing the whatever variables are stored in your history. And we also write closing all plots. If any open plots are there, that will be closed. Okay. So it will be the same thing, just the iterative formula will change here. So this is 1 by, so what was the iterative formula? It was half into x plus n by x, right? So first we'll find out what is half of x, and then we will try to find out what is half to n by x. So here you can see that I have taken this I as a variable, which is the your iterative variable, and x of 1, that is the initial value of x, we have taken as 1, and we are trying to find out the square root, say the square root of 27. So n we have taken as 27, and k you don't worry about it now. Tolerance initial value we have taken as some high value, you can take any value, like 1 I have taken. So first, if I write on this code, what will come? The tolerance is greater than 10 to the power minus 9. It should be greater than 10 to the power minus 9. So 1 is greater than 10 to the power minus 9. Yes. We go inside the loop and execute x1 of I. That is x1 of I is 2 here. So x1 of 2 is half of x. That is the first, the x new was half into x plus n by x, right? So first variable we are executing first, that is x by 2. And next variable, what is the next variable? N by 2x. If I multiply with half inside. So this is x2 of I, that is 0.5 into n by x. And this is this line number 17. X of I is equal to x1 of I plus x2 of I. That is half of x plus half of n by x. Now what is the tolerance? As I described, this tolerance is the difference between the successive values of x. So we are taking an absolute here. It is x of I, that is value of x at the current iteration. I is the current iteration. Its difference with the previous iteration, which is x of I minus 1. And in order to get a percentage tolerance, we divide it by x of I minus 1. So this tol basically gives me what is the difference between the successive two steps. And here I equals to I plus 1 means we are advancing the variable to the next iteration. Again, it will find the tolerance here. Then again, this from line number 21, this execution will go to line number 11. Then again, the same thing will be repeated, and it will go on till the tolerance is greater, not less than 10 to the power minus 9. Any doubt with any line of the code?
Yeah, so I guess that in the line number 13 and in the line number 15, instead of x, it could have been say x1, x bracket 1, but x is not been declared.
Yeah, correct. Thank you. X is basically an array I have taken, correct. Any other doubts or queries? Is the code fine for everyone? Okay, I assume there is no doubt
So
of
I have a
anyone.
question.
Yes, please.
So line number 9, you have written the tolerance equal 1, but in while loop, you have tell tolerance greater than or equal 10 to the power minus 9. What is the difference between 9 number line tolerance and 11 number tolerance?
Can you repeat once again? I could not get your question.
Sir, you have written that line number 9 tolerance equal 1. But in line number 11, tolerance is 10 to the power minus 9. What is defined line number 9 tolerance and 11 number 9 tolerance?
Actually, line number 9, the tolerance which I have written, that is the initialization. That is, I'm initializing that variable to a very high value. Instead of 1, you can take it anything, 2, 10, 100, 1000, anything. That is for initialization. And line number 11 is the condition. That is till the inside the bracket of while loop, this tol greater than equal to 1e minus 9. So that is basically the condition for to enter inside the loop. So this is the difference. Line number 9 is the initialization, and line number 11 is the checking the condition for the whether I should execute the loop or whether I should not execute the loop. Both are the variable, both are same.
Okay, sir.
Is it clear?
Yes, sir. Clear.
Okay. Anyone else? Any other questions? You can just go
Sir,
through
may I
the.
say something?
Yes, ma'am.
Yeah, sir, actually, the candidate who has raised the question in line number 9, we have considered one value that any value, this tall is a variable actually. So
Yes.
without assuming any initial value, it cannot be done. So when we
Yes.
consider some value, it can be anything as you said. So
Yes.
within the loop, it will be updated at every iteration. So
Yes.
when
Yes.
this
Correct.
tolerances come down below or equal to this 10 to the power minus 9 value, then only it will stop.
Yes. Yes. That is what I described. Basically, okay, I'll tell it once again. So line number 9, tolerance is 1. That is, I have to, before going inside the loop, I have to initialize that variable, because otherwise, if I directly come to line number 11, it will not recognize what is the value of tol. And inside the loop here in line number 19, you can see it is being updated to the actual value of tolerance. So once that tolerance is less than 10 to the power minus 9, then it will come out of the loop. This loop will be stopped. So this is the logic behind any iterative statement if you write. Clear? Okay.
Yes, sir. Clear.
All the lines are clear, right? Any line you have doubt, you can tell me. Okay. So now I will run this code and I will show you how this error is reducing. Okay. So here I have taken the tolerance as 10 to the power minus 9. Okay. So I'll run this code. Okay. It has run. So now you can, I have to see X. There's some issue, I think. Sorry, this will not be 1. This will be I. So you can see here, I was trying to find out the square root of 27. So what is the exact value of square root of 27? If I find out SQRT of 27, sorry. So it is 5.1962. That is the exact value of 27. And see, using the this iterative Hennon's algorithm, we are getting, this is the X. You can see here X is equal to, first value we assumed it as 1. Then next value it moved to 14, which was totally different from our solution. Then it moved to 7.96. Then it moved to 5.67. Then it moved to 5.21. Like that, it is slowly approaching your exact value, 5.1962. So I can just plot these values. For plotting, there is a command in MATLAB. You have to give figure first. So figure command basically opens up the figure. Now you have to give the plot command. So what you want to plot here? You want to plot X, right? The values of X. So we will see this. See, if I just increase this is 10 to the power minus 9. I say I make it 10 to the power minus 15. There'll be more values, right? See, you can see here, initially the value is 1 I have taken, then it moved to 14. Then gradually it has saturated to a particular value. 1 second. I'll just plot it for you. Just with the points I'll show you. See, you can see these points, I think. I'll make it darker for you. So you can see here the values, right? First it was 1, then it moved to 14, and gradually it reduced, and now it is converging to a particular value, 5.19. So that is giving me the square root of 27. Is this clear? Or should I describe it? Should I explain it again? Any doubts? Any questions? Anyone? Just interact, otherwise this will be a one-sided class.
No, sir.
Okay, fine, right? Okay,
Yes, sir.
so now I'll just move to, okay. Now we will see in MATLAB again. I will do just after some time. We'll now switch to our notebook. The screen is visible, right? The notebook.
Yes, sir.
Right.
Yes.
So now we have learned how to find the square root of a number using any technique, using an iterative technique. Now you can ask me, sir, how to find out the fourth root of x? How to find out the fifth root of a particular number? So we need to find out a generalized formula for finding out the nth root of a number, kth root of a number rather. So we will try to find out an iterative formula for a kth root of a number, okay, using the same Hennon's algorithm. So here we are trying to find out the kth root of a number. That is x power k is it in the same process. You can also try and find out what is the iterative formula for this, just following the same process. X square equal to n, we'll just replace square here by k. So x is n by x power k minus 1. Then we will divide by k both sides. So now we will write this x by k as x. We have to just LHS, we have to keep x, right? So x minus x by k plus whatever was there. So this keeps the same thing, right? X can be cancelled and we'll get the same equation. So now we will try to find what is x new here. X new is basically x into n by k x to the power k minus 1. If we just manipulate, mathematical manipulation, if we do x into k minus 1 by k n by k x to the power k minus 1. Just a second. So this is the iterative formula for your x new. If we want to find the kth root of any number. So here, what was for the square root of a number? What was the value? What was the question? What was the iterative formula? It was basically half into x plus n by x. So this is a special case of this formula. In this formula, if we substitute k equals to 2, what will we get? X is 2 minus 1 by 2 is 2 plus n by 2x, right? So which is x into half into, sorry, half into x plus n by x. So basically this is the generalized formula, that is x new equal to x into k minus 1 by k plus n by kx power k minus 1. If you remember this formula, we can get to the square root, the cube root, the fourth root, fifth root, 10th root, anything you can find out. Is this derivation clear?
Yes, sir.
So I have a question here that, I mean, while
Yeah.
formulating such a relation and while representing a new value in terms of the old ones, how to ensure that whatever we are writing, whichever expression we are writing in the right hand side is going to converge?
I could not get you.
So my question is that here, I mean, in the equations, we are writing a, I mean, the new value in terms of the old values.
Yeah.
But my query is that whatever we are, whichever expression we are writing in the right hand side, so how to ensure that this right hand side expression is going to converge? I mean, how to ensure this thing?
This is mostly, this was done by trial and error only, I think. Most probably. Yeah. What else? We have to do it by trial and error. We have to the right hand side expression, we have to go by trial and error only. Means,
Yeah, because I was thinking that, I mean, we used to study the convergence of the series, I mean, topic in mathematics.
yeah.
Probably it has something to do with that thing that, okay, we come up with an expression and wherein we can compute the limit kind of thing, something, some sort of that thing. And finally we reach to a conclusion that, okay, this is going to be converged.
Okay. Yeah, it can be. Okay, as far as I understand, it is based on the trial and error. Okay, I'll check it and I'll get back to you the
Yeah,
details
sure,
about
sure.
that.
Yeah, sure. Yeah, thanks.
Thank you. Anyone else? Any other queries or questions? Okay, so in the chat section I can see. Yes, Remia, can you tell can you unmute yourself and ask what is your question?
Hi, it got
Yeah.
cleared when you change x to x of 1, x of I
Uh,
minus 1. Previously, it
y-
was wrong.
y-
You wrote it as x, then you later changed to x of I minus 1, then I
yeah, yeah.
equal to 2 makes sense.
Yeah, yeah.
Yeah, it's cleared. Thank you.
Okay, okay. Right. Yeah. Okay, so now we will try to implement this in MATLAB and we will see how our value is converging. The similar kind of exercise. We'll just try to see. Just remember this expression or note it down. We'll see it in MATLAB now. Is the MATLAB screen visible?
No, sir.
It's not visible?
No,
Okay.
sir.
Okay, okay. Just a second.
Not yet, sir.
Okay. Now, is it visible?
Yes, sir, visible.
Okay. Okay. So now here, similar kind of code we will write. Just we will change this x1 and x2, right? So this code is basically a generalized code, right? So we can find the square root, the or the cube root or the fourth root, anything we can find out from here. Yes, your voice is breaking. Hello? Can you come again, whoever was speaking? Or you can type in the chat box also. Hi, who was that speaking? Anyone? Okay, fine. I'll continue. Okay, so here in MATLAB, you can see in this Hennon's algorithm, a similar kind of code I've written. You can just understand this x1 and x2 have changed basically. So it was x into k minus 1 by k, right? So basically I have written the same thing, 1 by k into x of I minus 1 into k minus 1. And x2 of I is n by k into x of I minus 1 power k minus 1. So then x we are updating by adding these two numbers. And then again we are finding the tolerance and we are iterating over the same thing. So now suppose I want to find out the cube root of 27. Okay. So we all know the cube root of 27 is how much? 3. So we will see up to 9. Suppose I'm giving it. Okay. Let me give the tolerance as 10 to the power minus 9 now. And I'll just plot it also here. So it is figure plot x by so you can see here the plot is visible on your screen.
Yes, sir.
Okay, I made it darker for you. So you can see the first we assume the value as 1, right? This is the at the leftmost side of the curve, it is 1. Then it moved to 3 point something. Just a second, I think I have missed it. Okay, k is 10. I have given it. Should be k is the which root you want, the third root, the cube root, or the fourth root. So k is basically 3 here, and n is 27. I had given wrong one. So if we run this, now you can see your value is converging. Just make it darker. So you can see here the values. Initially it was 1, then it moved to a different value 9.5, and then gradually it converged to 3. So this value is how much? We'll see the value of x here. It is almost converged to 3 exactly. So any value you can find it out like this, any root of a number using a numerical technique. Because say fifth square root, we have an analytical technique. Rather, by that repeated division technique, we have a technique at least for finding out the square root. But how can you find out the fourth root, fifth root, all these things? This is not possible. When there was no calculator, people used to solve by this kind of techniques, this kind of iterative techniques. If you do it in the actual thing like on pen and paper, it will be, yes, I understand it is computationally expensive, but if you do it in a programming language, it is just a matter of few seconds. You can get it. Any doubts on the MATLAB code? Anything? Yes, Dr. Srimanti, you are not audible.
No, sir. I had some network issue. That's why I left out and then I have
Okay,
joined.
okay.
Yeah, okay, sir.
So is it clear, or should I repeat it again? Anyone, you can tell me. There is nothing. I can repeat it. Any doubts? Anything? You can just let me know. Okay, I'll just take a 5 minutes break, and then last hour we will start. 1 hour, 1 more hour we will start. Just 5 minutes. I'll take a break and I'll come back. Okay. So I'll start the next part of the class. I'll share my screen first of all. So this was all about Hennon's algorithm, in which we were finding the kth root or the integral root of any number. Now we will switch to a different technique, which I think everyone will be familiar with it, and that is the Taylor series. We'll try to find out, and we'll try to see what is Taylor series, what is the motivation behind the Taylor series, and we'll see the implementation on MATLAB also. So what we do in Taylor series basically. So we try to find the value of a particular expression or any algebraic expression. What is the value of that function or algebraic function? What is its value at a particular value of x? Basically, we try to approximate f of x, right? Approximate f of x. So how do we do that? So first I'll write the series formula for Taylor series and then I'll explain it. So what is basically the formula? It is f of x plus h. It is equal to f of x. I will write it f of x naught plus h into f dashed x naught, h square by 2 factorial, f double dash x naught, h cube by 3 factorial, f triple dash x naught, and this will continue, right? So this is an infinite series basically. To represent any kind of function, we can use this series. So now we will see what is how we can. This is an infinite series means we cannot get a finite value. You may think like that. We cannot get a finite value of the function from this series, but it is not like that. What we do is we truncate this series, and this part from the third term onwards we call it as computational errors. Computational errors. And this is what the f of x naught plus h f dash x naught, that is the value of the function. So basically we can simplify this expression and we can write f of x naught plus h is equal to f of x naught h f dash x naught plus some error terms. We don't need to think into those things. That is the error terms. So now we will see an example how what is this h, what is x naught, all those things. So suppose you are asked to find sine of 0.75 using Taylor series using h equal to 0.25. H is given as 0.25. Okay. And Sorry, there was a network issue. Am I audible now?
Yes, sir.
Yes, sir.
Okay. So there is a network issue, so there is a delay. So suppose you are asked to, we are discussing about Taylor series, right? So suppose you are asked to find out the value of sine of 0.75 using Taylor series, and your step size, that is h, is given as 0.25. Okay. So now you need to first, you have to find out how many steps I would require. Again, this is an iterative method. So you will be iterating and you will be doing in steps. So your h is given as 0.25, right? So h is 0.25. This x is given as the value at which you want to find the functional value is 0.75. So what is the number of steps? We tell it as ns. Can you tell me how many steps do we need to follow here? Anyone?
Three
Any
steps.
idea? Yeah,
3 steps, I guess.
yeah, correct. So how did you get to 3 steps? Can you explain?
Basically, we need to approximate of the function value is 0.75 and the step size is 0.25. So we need approximately iterations to reach nearby like that.
Yeah, correct. So basically, your ns will be, you can find it out like this, x by h, which will give you 3. So by intuition also you can find out. Basically, in steps of 0.25, you have to reach to 0.75. So basically, first you have to find sine of 0. Then you will move to 0.25. Then you will move to 0.5. Then you will move to 0.75. So sine 0 is known to you. It will be given to you. First, you have to find out. First step, you will get sine of 0.25. Second step, you will get sine of 0.5. Third step, you will get sine of 0.75. Is it clear? Okay. So now how do we apply this formula? So what is the formula for me? F of x naught plus h equals to f of x naught plus h f dash x naught. We'll not consider the further terms, which are the error terms here. So for the step 1, so step 1 is, so x naught is, first you are starting with 0, right? So x naught is 0 here. And your h is 0.25. So sine of f of x naught, I'll write the equation once again. F of x naught plus h, f of x naught, h into f dash x naught. So this will try to f of x naught, f of x is how much? Sine x, right? And x naught plus h is 0.25. So it is sine of 0.25 equal to f of x 0, that is sine of 0, plus h is 0.25, and it is f dash x. Okay, so f dash x is cos x, right? So it is cos of 0. So from this we can find out sine 0.25 equal to sine 0 is 0, cos 0 is 1. So sine 0.25 is 0.25. From this Taylor series algorithm, sine 0.25, first step we find out as 0.25. Can any one of you tell me what will be x naught for the next step? So I'll pick someone from the chat. Wait.
The
Yes.
value of the
Hmm.
step 1 will be the initial value for the step 2.
Yeah. So okay. So 1 second. I'll just ask someone from here. Asif, can you tell? Uh, if you are there, Asif, can you please respond? Okay, I think he's not there. Then I'll move to the next person. Atikur is there. It doesn't matter if you tell wrong. You can just unmute yourself and tell me whatever you think. Next is Mr. Chandrasekhar is there. Okay, fine. For the second step, x naught is 0.25, right? H is again 0.25. So it will be sine of 0.5 equals to sine of x naught. So x naught is 0.25 plus h is 0.25 cos of 0.25. So from here we will get sine of 0.5 is equal to sine of 0.25. We got it in the last step, right? What is it? 0.25 plus 0.25 cos of 0.25 is root over 1 minus sine square 0.25. So it is 1 minus 0.25 square. So if we simplify this, sine of 0.5 will be 0.25 plus 0.25 root over 1 minus 0.0625. So if we try to find out what is the value here, 1 minus 0.25 square root of 1. So this will give me 0.4921. So from the second step, we obtained sine of 0.5 as 0.4921. So if we move to the next step, this is the last step, right? So again, x naught here will be 0.5. H is always 0.25. From this, if we try to find out sine of 0.75, it will be basically sine of 0.5 plus 0.25 cos of 0.5. So this will give me sine of 0.75 equals to sine of 0.5 from the last step we have got 0.4921, 0.25 square root of 1 minus sine square 0.5. Sine square 0.5 is 0.4921 square. So this will give me how much? 0.4921 plus 0.25 into square root of 1 minus 0.4921. So this is giving me around 0.7097. So after 3 iterations, we found out the value of sine 0.75 is around 0.7097. So now we don't know how we are approach whether we are exactly towards the solution, because sine 0.75 we don't have a standard. We can find it out using the calculator. So I'll just find out what is the exact value of sine 0.75. It is 0.6816. Exact value. So you can see how much is the difference. There is a quite a bit of difference in the computed value of sine 0.75 and the exact value of sine 0.75. So can you tell me any idea on why this error came first of all, and then how we can minimize this error? Any idea? Anyone can share your idea?
So this could be the remaining terms in the Taylor expansion, which we ignored as the computational errors.
Yeah, that is one answer. Yes. So how do you think?
One maybe another solution. May I say something?
Yeah, just a second. I'll just complete what the previous person was telling.
Yeah,
Yeah,
sure.
yeah. I'll just come, everyone. Yeah. Who was talking previous to this? Can you come back?
Yeah, so I said that this
Uh,
error could be because of the remaining terms in the Taylor expansion and which we ignored.
yeah, that is one. Obviously, that is correct. How do you think we can remove this error? Means how we cannot remove it exactly. How we can minimize the error?
So yeah, so we can minimize the error by reducing the step size could be one thing.
Yeah,
So as to make the this derivative slightly more smooth,
yeah,
and then we can go up till the second derivative also if possible.
yeah. That is correct. One of the remedies are correct. Yes, Mr. Raj, you want to say something? Yeah,
Yeah,
Mr.
actually,
Yes.
yeah. I was thinking, see, if is there in relation between step size also, like if we reduce the step size more, can we go more near to the exact value?
Yeah, yeah, correct. Yeah, sure. Thank you. Madam, you were telling something?
Yeah, by reducing the value of h, we can reduce the error, approximation
Y-
error.
Yeah, yeah, correct. All of you are correct. Raj, you can lower your hand.
Yeah, sure.
So yes, you are correct. You have to reduce the value of h. Okay. So now, if you reduce the value of h, what is the problem? The problem here is you will have to do more steps. That is, it becomes computationally expensive, right? So this is one of the disadvantages, but obviously this computation we can minimize using our programming. So that is what we will see now. How is the error reducing? Whether the error is reducing with the increase in age or whatever is there, we will see it through a MATLAB code, because we cannot. It will be very computationally expensive for us to do in MATLAB, to do it manually. So I'll show you in MATLAB the same thing. Is the MATLAB screen visible?
Yes, sir.
Okay. So here, okay. So here, previously what we were doing is in MATLAB, we were writing in a normal script file. These are called the editor where we are writing. It is a this Hennan's algorithm or whatever we are writing in a normal script file. But when we want to write a more concise program, what we do is we usually write a function for that. So, all of you, are you familiar with writing a function in any programming languages? Are you familiar with it? Just you don't need to know what is a function and all, just the basic structure at least. Anyone not familiar with writing a function in MATLAB?
No, sir.
You're not familiar.
Yes, sir.
Okay, fine. I'll just tell you. So here what we do is the first line you can see here. Here we'll write, this is the syntax. We have to write function word. Then in this third bracket, we will write what are our output variables. And here we'll give the name of the function, which is I have given as Taylor series. And in that bracket, we'll give the inputs, right? Then we will call this function from the command window and we will execute it. So here just try to understand what is this value taught, true value, error, and H. These are our outputs, and the input is ns we are giving, which is number of steps, and x. X is the value of the value at which we want the functional value, right? Is basically this number of steps I am taking as input, not the h. Or we can take h also as the input. That is better, I think. Leave it. So here we are taking number of steps as the input, and x, that is the value of the value at which we want the functional value. So here I am writing this, I am taking this multiple number of steps so that I can show you that with increasing value of h, if I increase the value of h, your error will be more. That if I reduce h, your error will reduce. I am just trying to show you here that using this ns, if we take that is the number of steps as different values, I will show you how it is changing. So here, what we are doing is sims of y. So in order to we have a function here, right? Sine of x or e power x. In order to describe that, we have to describe it as a symbolic function. In order to describe as a symbolic function, we are using this sims variable. The sims command in MATLAB basically tells tells MATLAB that y is a symbolic variable. It is a variable. Just think of it as a variable. Now I am writing func equal to sine of y. So this basically func, you tell MATLAB that it is a sinusoidal function. Func deri I have taken as the derivative variable, which is diff of func. So MATLAB actually is very user friendly, and there are many inbuilt functions in MATLAB. So that makes it much more easier to use. So we are finding the derivative of the function. Then we are finding out h, that is the step size. So I'm writing here h of kk because here kk is the index of the step size. That is, first we are using, say, step size as 1, then number of steps as 1, number of steps as 2, like that we are using. That's why we are using a kk index here. So h is basically, as I told you, it is x by ns. K and p I am just initializing as 1 and 0. Now it moves into this while loop. So while k is less than equal to ns of kk. So here in the while loop, I am taking the condition as the number of steps, right? So I have determined, say I have to find sine of 0.75, and I have told you that there are 3 steps. So k is the step index. K is the step index. Okay. So till this step index is equal to the number of steps which I want, till that point your function will continue. Here in line number 17, we have basically written f1 equal to subs of func comma p. Subs command is usually used to substitute a particular variable with a particular value. So func, what is func here? Func is sine of y. In place of y, I want to substitute as p. What is p? For the first step it is 0, then it will update itself. What is f2? F2 is the second term, that is subs of func deri comma p. In that f dash x, we are substituting p, that is 0 for the first step. Then we are finding the functional value. What was the functional value? It is basically f of x plus h into f dash x. F of x is your f1 here, and your f dash x is your f2, and we are multiplying with h. Then we are updating this p. What was p? Just be careful here. P was 0 initially, then it will be increased by h. H is say 0.25. So for the next step, we have to evaluate the function at 0.25. So 0 plus 0.25. Next step, it will be 0.25 plus 0.25, which is 0.5. Next step, it will be 0.5 plus 0.25, which is 0.75. In this way, we are updating the value of p. In 25th line, we are just increasing the step size, number of steps, the step index rather. So once this while loop is completed, it comes out of this while loop. It goes to line number 23, where basically here you need to understand. this value taught is the value of the function at different step sizes. Okay. So I have written here VPA value comma 5. So VPA command is basically used in MATLAB in order to here actually this y I declare as symbolic variable. So if you don't use this VPA, it will give you a very means it will take all the decimal places up to say 20-25 decimal places, which we don't want. So what we are doing here is VPA of value comma 5. That is we want only up to 5 decimal places. Then in line number 31, we are trying to find the true value. So this is our computed value from Taylor series. I'll write it in comments. Computed value in Taylor's series. And this is the actual value. That is, we are substituting directly the functional value subs of func comma x. That is, say func is sine x. In place of sine x, we are substituting the value of x here. What is x? X is the functional value at which we want the function, that is 0.75. So from here we are getting the value of the actual value. Then we are finding out the error. That is, what is the error between the computed value and the true value. Then we are moving, this kk is the step size index. So this one for one step size it is completed. Then we are moving to the next step size. And then because this k and p has to be initialized to their original values, because this k equals to 1 and p equals to 0 was here in line number 13. For every step size, it should be a fresh computation, right? The value at a particular step size, say I take step size as 0.25, I get a value of sine 0.75. So when I do for the next step size, say I take the next step size as 0.1. So your value of sine 0.75 using step size 0.1 will not be dependent on the previous value. So you should start a fresh computation. So in order to start the fresh computation, we are again bringing back the value of k and p to their original values. Is it clear, or any confusions, any doubts you can tell me? First of all, did you, every one of you got what I was explaining, or any doubts?
So can you show that code again?
Yeah, sure. Yes.
So ns and x are the arguments to the Taylor series,
Yeah,
and
that is the input.
yes, and whatever we are writing in the left hand side after this function keyword, are they the return value or what?
Yeah, these are the output return values.
Okay, okay, yes, thanks.
Any other clarification, sir?
No, by and large it is clear to me. Yeah. Thanks.
Okay.
Yeah.
Anyone else? Any doubts? So Srimanti madam, your students, they're not responding actually. I'm not able to understand whether they're getting or not.
Yeah, they are here.
So I called them by the names also, they didn't
Mubadil,
respond.
Iftikhar, I can see that you were here. Javed, if you have any query, please raise your hand or talk with him.
No, ma'am. Till now, everything is okay.
You understood the lines of the code, MATLAB code?
Yes, sir.
Thank you.
Okay, fine. So I'll run this code and I'll show. So just while calling the function, you just see here how I have to call the function. So this part you have to copy. Okay. and you have to paste it in the command window. Now these are the input, right? So number of steps I have to give and X I have to give. So say number of steps I for different number of steps, that is for different H values I want to run my code. So NS I have to give it as an array. So say I will give it as 1, say for 10 step sizes I want. So this is my NS. And what is X? I want the value of sign of 0.75. So I'll give X as 0.75. Then I will press enter. Now it is running. It is over. So now I will plot the error. Okay. So how to plot? Figure, comma, plot. I want to see the value of error, how it is changing with the step size. So your x-axis should be step size, that is H, and your y-axis should be the error. The error variable is ERR, right? If I press enter, so you can see here, right? As H is x-axis, so as H increases, your error also increases. That is, for lower value of H, your error is less. So you can see here, you can, 1 second. One second. I'll make it a bit darker. So you can see here the value for the different values of H, your for lower values of H, here the error is very less, and as the H increases, your error is reducing. Is it clear? As we had anticipated through our understanding of the mathematical problem, it is indeed true that as your H increases, your error will increase. And if you reduce H, that will obviously increase the number of steps, correct? But that will make your solution more accurate. Any other doubts, anyone?
No, sir. Everything is okay.
Okay, so fine. That's it for today. I'll just give a brief homework for you. Just try this, try to write the MATLAB code for this. So you only, I'll tell, just don't look into the code which I have. I'll not share these codes with you. You need to learn. So what I'll do is you take down the question. So f of x is equal to exponential of x. 1 second, just a second. Let's share the screen. So I'm giving this f of x as exponential of x, and you have to find this at x equal to 1 point, say 5, and you have to write a MATLAB code for this. Write a MATLAB code for this to find out. Everyone, please note down this question to find out f of 1.5 using step sizes of, I'll give different step sizes, 0.001, 0.01, 0.1, sorry, point triple 401, point 0001, 0.001, and 0.1. For these four step sizes, you have to find the value of this function, and you have to plot the errors. First, you do it for this. Okay, you write a MATLAB code for this and plot the errors. Is the question clear to everyone?
Sir, I have one query. Is
Yes,
this
ma'am.
x is equal to 1.5 the initial value?
No, you have to find the value of the function at 1.5, and you will
Okay.
start. You will start initial x is your 0. From 0 you will
Okay.
start.
Sure.
So everyone, before next Friday, you should do this, and you can send it to me, the MATLAB code with the results, at this email ID, or you can share in the WhatsApp group also. You can share in this email ID. It is shomodip.choudhury239@gmail.com, or in the WhatsApp group also you can share. You should do it before the next class. Okay. So these are the weekly assignments, and in order to get a certificate, you should submit these assignments. And at the end, there will be a short MCQ type quiz for this, and you have to secure the passing marks in order to get a certificate. Fine, everyone. The question is clear.
Yes, sir.
Okay, so basically, you have to prepare a Word document where your code will be there, and then this your result should be there. Fine, then we'll meet again on next Friday, not Saturday. Just remember this: your regular classes will be on Friday, 6:30 to 8:30. So we'll meet on next Friday, that is 15th of November at 6:30 IST. Okay. Okay. And I'll upload this recording in YouTube, and I'll share it in the WhatsApp group as well as in the through email. Fine. Then
Thank you
I'll
so very
close the
much.
class for today. Yeah.
I said thank you so very much. Yeah, it was an interesting session. Thank you.
Okay. Also, weekly I need to actually I'll circulate a feedback form, the Google form. You have to just write your feedback there. And actually, that is not for me. That is from the institute from where I'm teaching this course. There, they need the feedback for weekly classes. So I'll share a feedback form in the email as well as in the WhatsApp group. Please submit your feedback how you liked. Okay, fine. You can leave. Thank you. We'll meet again next Friday.
Thank you, sir.
Thank you so
Thank
much.
you.
Thank you,
Thank
sir.
Thank you.